And for our Cloud Hackathon Bluemix project, we've developed an application which utilizes the Watson image recognition technology from IBM to identify images of smart home devices and then build commands that the smart home controller understands in order to control these devices. The controller that we'll be using is Control4, and we have this set up at our home. The Control4 system is very modular and powerful. It has the ability to run native Lua scripts, which we will be using to send and receive commands from the Bluemix server. The system has the ability to turn on lights, play music, all within a properly configured room. The native Lua driver, which we have developed, will be demonstrated by my partner Louis Puche. But basically how it works is that the Control4 driver that we've written will pull a certain location, actually a text file, on the Bluemix server that contains the command for the Control4 box to execute. In just a few seconds here, I'm going to demonstrate the Control4 panel. This is the default login page for our Control4 system. Now, the reason that there's a login and password is because, as we all know, a smart home is a very relatively new and very sensitive infrastructure, and especially one that's connected to the internet. So we want to have at least some authorization to use this panel. Now, the way we're providing authentication here is through the use of the Passport module. And just to note, I'm using the Passport local module here, which means I have the username and password hard-coded directly into the app.js file. Now, this is relatively insecure. In the future, it would be highly recommended to introduce either two-factor authentication or at least encryption for the username and password. Now, the way the username and password are handled is also important because it's just the architecture of our panel here. It uses cookies. The Control4 panel that we've developed will use cookies to store commands and cookies to authenticate the administrative user. So if I type in some invalid credentials here, for example, admin password, this is an incorrect password. So as you can see, we're redirected back to the original Control4 panel login screen. If we check the cookies, we see that C4 admin cookie has been set, but with no value. So if I type in the correct credentials here, admin username password demo, and click submit, we're redirected to an auth success message, which then redirects us to a portal. And this is the main portal, meaning we have been authorized to be here. And the way we've been authorized is because the cookie value is Vlad007. Again, I'm not saying this is the most secure way to do things, and obviously it's not, but for demonstration purposes, here is a authentication system. Just so I show how all this happens, because it happens relatively fast and a lot of stuff happens behind the scenes, I'll elaborate a little bit because I mentioned earlier that a lot of this has to do with cookies. So just to show here, I'll open up the JavaScript debug console and I'll show this error. It's a failed resource to filter load resources because we haven't uploaded an image yet. Okay, so currently the only cookie that we have is our administrative cookie, which is fine. That means we're allowed to use the panel. So I'm going to drop the picture of a lamp and see if Watson will identify it. Just a few seconds, and we see that it has indeed identified a lamp with 77% certainty. Now, going back and emphasizing the cookies, we see that there is a new cookie that has been set called C4 command with the value lamp. Now, what happens is once Watson identifies that this image is indeed a lamp, a cookie gets set telling the browser that this is a lamp. Now, the way the cookie is handled is the important part. I utilize the cookie parser library in order to be able to grab the browser cookies and parse them for their data. Now, once an image is uploaded and processed, once again, I'm going to upload the lamp. Once an image is uploaded and processed, a cookie is stored, and then the check command get parameter gets executed. Now what this does is it checks to make sure the cookie isn't empty, And then it verifies that the user is an administrator once again. And finally, it takes the contents of that cookie and saves it to a file called command.txt. Now, if we try to access that file now, since Watson has just identified that this is indeed a lamp, we check the command text file, and sure enough, we see that it is a lamp. Now, if I was to go back and similarly upload a picture of an auditorium, or here, if I was to upload a picture of a door, Watson identifies it as indoors. So if I go back to the command text file, I notice surely that indoors has been set. Okay. Now, if I check my cookie, I notice that the indoors value is there and that the file is still present. If I refresh, the file is there. So if there's a few options in the panel. If I want to clear the command, I can do so. I click here, and I'm instantly redirected back to the Control4 panel. If I check my cookies, the C4 command cookie has indeed been cleared, and the command text file has been deleted. Now, the C4 controller identifies that there is nothing here because I've updated the text file contents, so it just waits, and it'll pull every few minutes to check if there's a new command. The interval at which it pulls can be set and adjusted at any time as well. And finally, when the user is finished using the panel and issuing commands to his or her smart home device, if they wouldn't want another individual that's accessing the same computer and same web browser, meaning using shared cookies and saving this authenticated session for the control panel, the user may choose to log out. Now, what the logout does is it'll clear the C4 admin cookie, which we'll see right here, and it'll redirect us back to the initial login screen that was shown at the beginning of this video presentation. So, press the logout, and we check the cookie, and as you can see, no cookies are here. The session has been deleted, and now if we attempt to access the portal location that we were previously at, we get redirected back here. We're not given access to this secure environment. Now that we understand the functionality of the Control4 System Administration panel, I'm going to hand over the presentation to my partner Luis Puche, who will give a demonstration of the practical applications of this project. He'll demonstrate things such as powering on lights and playing music. Thank you for your time.
Hello, this is Luis Puche, and I'm here to elaborate a little bit more about Lua drivers and the Control4 interface. As Vlad mentioned, Control4 works through a centralized controller. This controller manages input and output of all devices in the smart home. It handles all the signals, one of the notable features being the mesh Zigbee network for wireless devices. The main controller of this system uses files called drivers as interfaces to other devices. These drivers contain all the information needed for communication with that device, no matter if it's serial, IP, or IR. Everything necessary is just compacted into a single driver. Basically, each television, each light, each thermostat, each door lock has its own driver. For Bluemix, I had to create a driver which would work from a pre-established data file in order to read and perform actions based on object recognition. Right here is the view of the driver editor. This driver editor works through HTTP bindings, right here, functions, and is coded thoroughly with Lua. Now, the first variables have to be added, which is the variables that Control4 is actually going to use, that is text buffer and changed. And over here is where the command is received. Receive async is what happens to the data, and this takes the data and stores it into the variables which are readily available from the Control4. Down here, the command get buffer is executed every time to fetch the HTML info from the server. This is the Control4 composer, and from here all the devices that we are going to be using are managed. For example, right here, the only room we care about is the LCP room, which has the Bluemix driver put in already. Several things had to be done to the system so that they worked through Bluemix. In the agents section, I had to set up announcement for a greeting that you will see later. as well as in the variables section of the agent, I had to set up several different drivers. Bluemix, true or false, which right now is active. So this deactivates Bluemix querying, and this activates Bluemix querying. The buffer, which is basically the last message that was received, changed, which is the last, which means if the last message is different from the previous one on each query, and last valid message, which is messages which have been put in to work with the system. Now we move on to a thing called macros. And macros are the ones that manage the process. And here we created one that's called process Bluemix. The details of these are seen right here. This is what happens when process Bluemix is executed. When the buffer is equal to lamp, it will execute this. When the buffer is equal to indoors, it will execute this. And these are basically the actions that are being enacted once Bluemix is triggered. Now before it gets to this part, it has to go through the actual variable, which changes. Now Bluemix, right here we're setting up a loop. And here we get the HTML buffer, again, that queries the driver. It fetches the information. It changes the local variables from the driver to the ones that are here. Then if it's not equal to true and the last information was valid, then it will execute the macro. Then delay 3 seconds to allow it to rest. Now, if we go back to the driver variable, the macro, which is right here. Hello, and I am here to demonstrate the smart home interface with Control 4 and Bluemix. Here we go, and we have 4 pictures. We are representative of things around the house or actions around the house. So right here we have a lamp, which is an object. Could be anything, really. Anything that can be controlled and identified can be joined into this system. Then this is our room. Just going around the house. Oh, this is our room. We want to trigger something from just looking at our room. This is the entry of the house. Just looking at the house, about to go in, getting things ready for us. And right here is the exit, as in we're leaving. So first of all, we begin with our house. We just got to our house. We want our lights, usually want our lights dimmed. We want a welcome message. So here we go. Oh. So here we go. We're putting in the house right here. It is recognized. And light dims. As well as the welcome message. We go back here. So we look at a different object. We go around the house. We realize, you know what? I don't want the light out on the house right now. I'd rather just have my light off. So we go, look at the lamp, and we trigger this from looking at the lamp. So we looked at the lamp, we're like, toggle, turn off. And it turns off. Right there, that's the dimmer that manages that light. Okay, we're done. And then we go to our room. We want something to happen when we go to our room. So we go and we select our room. We put it right here. Okay, we just looked at our room. We want to trigger an event from just looking at our room. So light dims on again in our room. And music starts playing. Now we're looking back. We are done. We're about to leave. That's the door. And that means that music turns off, light turns off. Thank you for watching.